let's take a minute to look at continuity measurements. Here I've got a regular snap switch, like a light switch. I don't know if you can see it or not, but let me zoom in just a little bit. It's an on-off switch. Right there you can see, I can see the word on right there. There it is, on. So remember, with light switches, up is on. Make sure you don't install it the wrong way. The light switch has 2 connections on it, 2 screws. If I'm checking continuity, I want to see if it's got a continuous circuit, if the switch is good. So what I'll do is turn these screws in just until they contact. I don't want to over tighten them. The reason I do that is so I have a good connection. You know, I have to trust my measurements, so I don't want to loose screw on that. So what I'll do on the meter, I'll set it to ohms. This is the Fluke 325. It's going to adjust itself to continuity. What I'll do before I do anything else is I'll check the meter. I'll put the probes together and get the beep. Okay, so that's what I'm looking for, is a beep here. I'll put probes across the screws. I get nothing. Switch it. So that's a good switch. Okay, a simple continuity test. You know, I would do that if I suspected the switch was bad. I'd take one of the wires off, make sure the power's off, put the probe across it and see if it's got continuity. Here's a push button, normally open push button. Remember that the green blocks are open blocks, open contacts. I've got 2 screws on this. I'm also going to just snug those screws up a little bit. I don't want them to be really loose. But if they're loose, I don't get good connections. Okay, I'm not going to tighten them. I don't want them to be loose. Same thing on this one. I'll put the probe across the 2 screws. Got no beep. I push the button. That's a good switch. Okay. So here's another one. This is a start-stop push button. The only trick on this thing is to make sure that, you know, when you press the green button, which is the start button, you want to make sure the green switch is moving. You can see that pin coming up on the green contact block. You know, sometimes you'll get this backwards, like so. When you hit the green one, you get the red one. So check before you start to wire. Make sure that you've got the actuator, this thing, in the right orientation on the switch. And I'm going to double check just to be sure. It's green. Okay. Same thing here. I'll check, see if my screws are loose. I'll just run them in, not too tight, just so they're not loose. I'll check red first this time. Red's closed, so it should beep right away. If I press it, it'll stop beeping. That's good. Let's check the green side. That's good. That's a good switch. Here's another switch. It's a selector switch. Okay. This one has a green contact on it. It's open. Let me zoom in on that so you can see a little bit better. You can see the gap that shows up there, the gap. When I turn the switch, close it, open. The other side's got the red block. You can see it's off right now and it's closed, normally closed contact. When I turn on the switch, I open the switch, I open the normally closed contact. So I've got one of each on this one. The open side is a 2324. The closed side is a 1112. 1112. Let's check it out and see what it does. Right now is it on or off? It is off. So I should get the red beep. I'm going to leave it zoomed in. Kind of hard to do with one hand. Okay, I get the red beep. I'm going to turn off the switch. I should not get a beep. Should have no continuity. It's hard to tell if I'm making a connection there. I'm going to hold this one. Let me zoom out so you can see what I'm doing. Okay, no beep. It's on now, so I should get a beep on the green side if it's good. And then if I turn off the switch, I should get no beep. That's a good switch. Notice on this switch that I think that if I pull this black plastic off the back side, I could attach more contact blocks. It looks like that orange tab there would snap over this tab. So I could stack the contact blocks if I had more. I don't have any more of these. I bought this switch on Amazon. I needed a switch for a project I was working on. And it was inexpensive and it showed up the next day. So I think that's a cover for the expansion of the contact blocks. If I look back at this switch, for example, you know, these things also will stack. These have screws on them, so let me take the screw out. Let me unscrew it here. Okay, let me tear it all apart. So here I've got the actuator. Here I've got the switch base. When I drill a hole through the panel, I will put the actuator through the panel, snap it to lock it in place, and then I'll tighten these screws down to pull it up against the door. Okay, so I'll hold it in with these screws. Okay, this contact goes on like so. This screw tightens down to hold it in place. But if I wanted to, I could add it to this contact block here, because the screws will go together here. So I can gang this switch, like have multiple contact blocks. If I need, let's say I've got a circuit that I've got one function on this open contact and another function on this open, maybe a seal-in circuit with a motor starter on the bottom one. Maybe the top one goes somewhere else. Okay, I push this button and they both move. If you can see that, the green switch is moving there. Okay, so sometimes you'll need more than one contact block, and this is an easy way to get more contacts. These two green switches close at the same time, so you could, you know, whatever your circuit requires, don't feel constrained by just having one open and one closed. Okay, I think that's all I've got for continuity right now. Well, let's do one really simple one, the simplest possible continuity test. Here I've got a jumper wire and alligator clips on the end of it. Okay, let me move all this stuff out of the way. So obviously I would expect this to be a good piece of wire. I have purchased alligator clips before that were not. Oddly enough, somehow they weren't connected inside, you know, underneath the insulation boot here. And I was really surprised by that. I couldn't believe it. I said, well, they have to be good. I just bought them, and I checked them, and they were not connected. So that's a good signal, right? One thing I'll mention about the meter is that continuity is a term that means low resistance. So the meter, if it goes below, I think the Fluke 325, if it goes below 30 ohms, it beeps at you. So if you have a low resistance that you're measuring, like a small, like a light bulb, for example, and you want the resistance of the filament, you're going to get a beep no matter what you do. And if you have a meter that has ohms separate from continuity, then you can just measure ohms without getting the beep. This one I can't turn it off. I can't deselect the auto select feature that it has. But it's a great meter. It's got everything you'd want on it. Let me zoom out. So there's the 325.